right. On this page, we're going to write y equals negative 2x squared plus 32 over x squared plus 6x plus 8. Negative 2x squared plus 32 over x squared plus 6x plus 8. And we're going to go ahead and do all of the stuff for this problem. So what should we do first? Factor? What do you guys see about the top? It's negative. We got to take out the negative. What else should we take out? 2, because we got a GCF of 2. So I'm taking out a negative, I'm taking out a 2. What does that leave you with?
X squared plus 32.
X squared minus 16.
X squared minus 16. So I've got the negative 2 pulled out in the front. Yeah, and that's difference of squares, which is x plus 4x minus 4. And then on the bottom, we're looking for what multiplies to 8 but adds to 6.
4 and 2.
4 and 2.
So the x plus 4 cancels out. That's your whole.
The x plus 4 cancels out. That means we have a whole. What is the x coordinate of the whole? Negative 4. So the leftovers would be negative 2 times x minus 4 over x plus 2. And then what do we do with those leftovers?
Plug in negative 4.
Plug in negative 4. So we've got negative 2 times negative 4 minus 4 over negative 4 plus 2. So negative 2 times negative 8 is positive 16. And negative 4 plus 2, negative 2. And 16 divided by negative 2 is negative 8. Okay? All right, what else do we have? Vertical asymptote, x equals, what'd you say? Negative 2. What else can we answer?
Horizontal.
X-intercept, what's the x-intercept? Positive 4. Does this one tell us that we have an x-intercept? No. Why not? There's no x. There's no x. Okay. What else can we see? There's a horizontal asymptote at y equals negative 2.
There's a y-intercept at 4.
Y-intercept at 4. 32 divided by 8 is 4.
There's a SA and an OA.
If there's a horizontal asymptote, there's not an SA and OA. There's either one or the other. And now we got to do our domains. So we have to know which values to skip.
Negative 4, negative 2.
Skip negative 4, skip negative 2. So negative infinity to negative 4, because it's smaller. U
Negative 4 to infinity.
negative 4 to negative 2. U negative 2 to infinity. Okay. All right, we got all the things. Now we're going to go ahead and sketch a graph for that. So I'm going to do it off to the corner on here. You guys are going to do it on your own paper.
Can we do it on, if we're taking notes on this, can we do it on this, or do we have to do it on another?
I want you to do it kind of big on another sheet of paper. Do it so you're doing it on your notebook paper and make it take up like half the page. Make it real big. Yeah. This is, well, so we're kind of done with the numbers like that because the next thing I'm giving you is a packet, so you can just call this example 1 if you want. So you're doing this, taking up like half a sheet of paper, making it pretty big. The thing that I'm looking at is I can see 4 and 4, so I know it needs to go that big at least, and I can see this whole left 4 down 8. So make sure your graph goes at least down 8, maybe a little bigger than that. Yep, at least down 8. So to the right and to the left, I don't know, maybe go to 10 each way. And you're taking up about half a sheet of notebook paper, take up a lot of space. On your graph paper, let's graph the horizontal asymptote at -2. And we got a vertical asymptote at -2. And we have a y-intercept at 4 and an x-intercept at 4. Oh. And we have a hole at -4, -8.
I'm back. Why you back?
I can tell.
So, what should your graph look like?
Wait, you said there's a hole at -4,
Yep, -4, -8. So, how should we connect these dots? What should we make this graph look like?
Triangle.
Yeah, please don't draw a triangle.
I have no freaking good from the elevator.
How do curves act when they get close to the asymptote?
They go away.
Yeah, so we know, we've seen enough of these graphs to know that it's going to look like this, right? It had to connect the dots, but it also had to follow the asymptote. So it's going to look something like that. And then, is the other curve going to be up here? Should the other curve happen over here?
No.
No, why not?
I feel like you should start.
Because the hole's down here. The hole's part of the graph. It's
It's a
missing,
hole.
but it's part of the graph. So the other part should be kind of going like that. Oh, that's a bad
What's
arrow.
that doing?
Something like that.
Something.
But the hole should be on the curve, and the curve should be following the asymptotes. All right. So if you used like some graphing technology to do it, this is what it would look like.
That looks a whole lot better.
It does, doesn't it?
It doesn't actually have
I got an extra one. I figured you was something back.
Okay. So there's all the things that we put on our graph, right? All right. Now on your notebook paper underneath, I want you to write range, increasing and decreasing, and max and min.
Since last week. Oh no.
All right. So we're going to find the range. What do we look at on the graph? We look at the y's, and we look at the y's. We look at the y's from down to up. So the lowest part of the graph is this, and what should be there if I drew it correctly? Arrow. So negative infinity is where the range starts. And we've got negative infinity up to negative 20, negative 18, negative 16, negative 14, negative 12, negative 10. And then what happens when we get to the hole?
It stops.
It stops. All right, so negative infinity to, what's the y value at the hole?
Negative 8.
Negative 8. Negative 8. Negative 8 is the y coordinate. Am I including that? Should I put a bracket there? No. All right, so negative infinity up to negative 8. We skip negative 8. Negative 8 to what number? We go up, we go up, we go up, we go up, we go up. Oh, we hit the asymptote. What's the asymptote at? Negative 2. And then when we get on the other side of the asymptote, we're using this curve now. We got negative 2 to 0, to positive 2, to positive 4, to positive 6, positive 8, 10, 12, to infinity. All right. Increasing, decreasing, how do we always do those?
Going down.
We draw our stick figure guy, right?
Yeah.
All right, so let's put him on the left part of the graph. We always start at the left because we're in America. That's what we do here.
America.
What is the x value at a left arrow?
4.
Negative infinity. So this guy starts walking. Which way is he walking?
Down.
Down. He is decreasing.
So he stops at 8.
He stops at negative 4 because he falls through the hole and dies. All right, and then we have to start with a new stick figure.
No.
Oh, this is decreasing.
And this new stick figure is still decreasing. Yep.
1, 2, 3, 4. 1, 2, 3.
And what is the x value at this dotted line? The x value, not the y value.
Negative 2.
Negative 2. The x value right here is negative 2. Okay? And then our second stick figure also falls and dies, but he falls on a dotted line. Maybe the dotted line chops him. I'm not sure. But he dies as well. We have to have a third stick figure. The third stick figure, again, starts at the left. What's the x value right here again? The x value? Wait, the x value? Negative 2. All right. What is this stick figure doing? He's decreasing. Now, right here, this is kind of like he's stepping on a little mound of dirt, but he's still going. He's not falling anywhere. It's not a hole. So he's decreasing, 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 decreasing. What's the x value over here? Infinity. All right.
It's negative infinity to negative 4 first.
So negative infinity to negative 4.
What does that mean?
Are we done? Because I'm annoyed. Are you done talking? Look at me. Are you done? All right. Negative infinity to negative 4. What's next? Negative 4 to negative 2. What's next? Negative 2 to infinity. And we got to make sure we got the u in there. What should I put for increasing? None.
Max and min are not, right?
Yeah, max and min are none. Why? There's no high point, there's no low point.
There's just a
Yeah, so this is where we remember
There's no valley.
that to make, there's no valleys, there's no mountains. To make a mountain, you have to go up and then come down. To make a valley, you have to go down and then come up. So I can see where this is like coming down, but it didn't go up before it came down. It's just coming down.
Well, that's good.
This one's going down, but it never goes back up again. That's why we know that there's no min there. Okay. All right, the next one is... negative 4x plus 20 over 3x squared minus 6x minus 45.
Leslie.
I thought it's something like
So what do we do first?
Yeah, you factor.
Factor. What type of factoring?
Grace.
So what's the greatest common factor? Negative 4. And then what's left over? X minus 5. Okay. What else do we have?
On the bottom.
On the bottom, this is GCF.
3. Okay. And then what's left over? X squared minus 2x minus 15. And we can keep going with that, right?
Yeah.
Find something that multiplies to negative 15 but adds to negative 2. 5 and 3.
You said that was right.
You didn't tell me the signs. X minus 5, x plus 3. Okay. So what do we see? Whole. What else do we see?
We see a. No, we don't.
Or we need to find the y coordinate, right?
Yeah.
So what's left over on top?
Negative 4x.
No.
Yeah, I mean, yeah, my fault.
And then on the bottom.
That's plus x thing across there.
Okay.
And then 3 times 3x.
So negative 4 over 3 times
3x plus 9. Oh, 5.
negative 4 over 3 times 8. 24. What's negative 4 over 24? Negative 1 over 6.
Negative.
Okay. Alright, what else do we see?
We see a lot of stuff.
There's 2 vertical asymptotes. Right? Or is it
There's one. Do you know why this one is not a vertical asymptote?
Why?
It doesn't have an x. There's no x with it. Yeah.
So the other one is x plus 8.
The other one is x equals
Negative 3.
negative 3.
I ain't going outside.
Alright, what else do we have?
So is there no x-intercept either because there isn't an x with that, or is that?
Yeah, so that's exactly right. There's no x-intercept because this is the only factor that's left over and it doesn't have an x with it. So this is an example where we say none. We don't say 0 because 0 is an actual answer. We say none because there isn't one. Somebody mentioned the horizontal asymptote.
Numerator is less than.
Would it be 1?
It would not be 1. It's not none.
0.
It's 0. So the degree on the bottom is bigger than the degree on the top, and that tells us it's 0. What about the y-intercept?
Would it be 4 over 9?
Yes, it'd be 4 over 9, but we need a little bit more in there. Negative, yeah, it's negative. And we do need the 0. Yeah.
Affirmative.
So the top and the bottom both could divide out a 5.
Affirmative.
And what numbers are we skipping on the domain?
3.
5. We're skipping 5. And we're skipping negative 3. So we should say negative infinity to negative 3, because that's the smaller one. And then negative 3 to
Negative 5. Positive.
positive 5. Good. And then 5 to
Infinity.
infinity. Good. Okay. We're going to draw this again. Take up another half a sheet of paper as you draw it.
No me gusta.
The reason we're drawing these so big is it's easier to see your range and your increasing and decreasing and your max and min if you're not squinting to kind of
How
see.
big should we make this one?
It looks like, so we've got, the hole is at 5. That looks like the biggest number, so maybe go to 10 again. Yeah, that's not bad. Or you could go up to like 7.
Oh, I'm so tired. I'm about to take a nap.
Look at that dog. Look at that dog.
I'm dead.
She said May 18 because you never know how it's like, I finished 12, yeah.
I did 15.
So on this one, I went ahead and I drew each of the asymptotes. I have a vertical asymptote at -3. And I have a horizontal asymptote at 0.
Yes.
And then I drew the hole at 0, -4/9. Or the y-intercepts, or the y-intercept at 0, -4/9, and the hole at 5, -1/6. So I can at least tell where one of the curves is. Or should one curve show up?
You said you drew what, 0? The dot, what does that dot mean?
That's the y-intercept, 0, -4/9.
Okay.
So where is at least one of the curves? Yeah, bottom right. So I'm gonna make it follow the asymptotes. And I don't know about the other one, so I'm gonna graph it on my calculator.
On the test, would you ask us to do all this?
Yep.
You said nope.
Yep.
See, senor.
She said yes. She said no. Like, she said no.
All right. So where should I draw the other curve?
At the top.
Top left, right?
Yeah.
My asymptote's at -3, so I just want to see what point is at -4. -4 has 4/3. So I put 1 point in there just to make my drawing pretty accurate.
¿Qué pasó? ¿Qué pasó? ¿Qué pasa?
Stop, that's not funny. Stop, that's not funny.
That's my mom right now. I'm just fine.
Right.
I'm fine.
I mean, what?
So that's about what your drawing should look like.
That's pretty.
You're not even done. All right. The range. We go from down to up.
You know, I love drawing.
Down to arriba.
So,
That part.
So -10, -9, -8, -7. It's got all these. It's got them all. It's got them all. It's got them all. Oh, I forgot to draw the horizontal.
Do you have to draw even though you're not going to be able to see it?
You should draw it because it helps you figure out your range and stuff. Okay. And then you're exactly right. It looks like we would get right up to the asymptote and say it's negative infinity to 0, but we do have this negative 1/6 that we have to skip. So it's negative infinity up to negative 1/6. That value gets skipped.
Skippity, skippity, skip.
And then it's negative 1/6 to 0. Good.
Then 0 to
Look at the
negative.
skip in that wrist.
And then 0 to positive infinity. Yeah.
There is more, but that goes right.
Now, remember how I've said that this unit, are we listening? This unit is more of a pre-calc unit than it is a Math 3 unit. So I want to go over some of this stuff with you because I think some of it you're definitely capable of. Like all the stuff that we were doing up till today, I think is pretty easy for you guys. Like you guys have done a really good job of answering those questions for me. I know that range is one that gives students a headache. So for us, when we take our assessment for this unit, the range question is going to be the bonus question. Okay, so we're going to practice finding the range and ask questions on it and try to understand it, but I'm not going to require that you get it right every single time until you freak out. Okay, so for this, we're just going to be considering these bonus questions. However, I do think you guys are pretty capable of doing increasing and decreasing, at least in problems that are not terrible. So increasing and decreasing on some problems would be considered extra credit. On other problems, I think it's a pretty reasonable question to ask. Okay. So let's go ahead and do the increasing and decreasing now. I just wanted you guys to know so you weren't feeling stressed out about it.
There's no decreasing, right?
Yeah, it looks like it increases the whole time.
So decreasing would be none.
So decreasing would be none. Alright, hey guys, I got an awful lot of laughing while I'm teaching, which is pretty disrespectful if you think about it. Alright. So what's the stick figure doing?
Walking up.
He's walking up.
Elevator.
Turning up.
And what is this number for the x coordinate?
10.
Negative.
Yeah, you're right. Here's negative 10, but it's an arrow, so we're thinking negative infinity. That was my bad. And then he's increasing, and then he gets stolen by a UFO.
Stolen by
And what is the x value here?
Infinity.
The x value, not the y value. The x value, negative 3. Okay? So this stick figure guy is done. We have to do the other curve, and we start at the left of the curve, always, because we're in America. So this is at negative 3 again. And what is this guy doing? He's increasing. He falls in the hole.
He gets eaten by an alligator.
And what's the value of the hole right here?
0.
The x value, it's 5, yeah. Alright, and then we get a new stick figure guy.
5 to infinity.
And 5 to infinity.
Exactly.
Okay, so how should we write this?
No, gracias.
Negative 3 to negative 5. Where is it?
And then,
5 to infinity.
perfect. Alright, max and min. Done.
Wait, why none?
There's no mountaintop, there's no valley. So, for it to be a mountaintop or a valley, it has to go up and then come down, or go down and then come up. And ours don't do that; it just goes up. It doesn't switch.
It doesn't go like that.
Yeah. All right, we're gonna do one more because the last one that I have looks a lot different than this. So one more example. We got y equals 2x plus 14 over x squared plus 2x minus 3.
Let's go Miss Rice.
So what do we have when we factor it? GCF,
X plus 7.
2, and then x plus 7. Good. What about the bottom?
Negative.
2 plus 3.
So for the whole, we say none.
I said 2 plus 3.
3 and negative. Oh, yeah.
I heard you. I almost said it.
What else can we see?
X plus 7. X intercept, which is -7.
Good.
Oh, 14 over -3.
I understand.
Domain.
We can do the domain. What values do we skip?
-3 and +1.
So negative infinity
Y equals
to -3,
horizontal asymptote.
and then -3 to,
1.
and then
Uno.
To beyond.
okay.
To beyond.
What else can we see?
The vertical
Horizontal
asymptote is
and
-3 and 1.
X equals -3, X equals 1.
Oh, I thought that was 7.
And then the horizontal asymptote is SA.
Y equals 2.
Not
Is there one?
Is it?
Wait, tell me why.
because the denominator is higher than the numerator.
So if the degree on bottom is bigger than the degree on top, we do have one.
0.
It's 0. Good. Okay. So we're drawing our graph. Everything that we know so far.
What was the whole?
None. Pay attention.
We haven't really drawn one of these before. We've seen ones where you had 2 vertical asymptotes, but we've never drawn it.
Wait, we need one?
Yeah, this one has 2 vertical asymptotes.
So at what number is the one on the left?
So this one's at -3. This one's at +1. What's the decimal for -14/3?
I mean, -4.666.
-4.666.
Oh,
Okay.
don't say them numbers.
So there's our y-intercept. -4.66666.
That's the devil.
-7, 0 is going to be way over here. We're just drawing what we see. That's it.
Where we get -66666?
That's this
Whoa,
written as a
whoa,
decimal.
whoa.
It's -4.66666.
Whoa.
Sorry.
You're dangerous.
-4.7, is that better?
Yeah.
Yeah. Repeating.
So, how do these curves act? What should they do?
Should make like
Follow the asymptote.
So we got a point right here.
so weird looking shape.
The left of the point is going to do what? What's the curve do at the left of this point?
Go to the left.
It goes to the left, but how far up or down does it go?
Not that far.
Not that far. It's getting closer to the asymptote, right? What's it going to do over here?
Go up.
It's going to go up. It's going to get closer to the asymptote, right?
I don't know what to do at the bottom. Just like go all the way around.
Yeah, it kind of, you got asymptotes all the way around, so it actually goes like this. It doesn't go clear up to the asymptote, but it goes like that.
It's a parabola.
That's
-14/3 is -4.7.
So now we have a max.
Yep, we're going to have a maxis.
A maximum.
Yeah.
All right, let's go ahead and graph it on our calculator since we
Wait.
definitely need to see some
So
more of this
how do we
one.
know what way the errors are going? Because I don't think.
You follow that.
The asymptote, the curve always gets closer to it. So you just have to follow it.
So what if I accidentally draw like this?
You're wrong.
How do I know it's going up?
Because we've seen enough of them to know. We're just doing it. The other thing is, I'm not gonna remember. I'm saying this is kind of a pre-calc concept.
Yeah.
I'm not gonna ask you to graph one of these without a calculator and have you give all the details. I just am going over it with you so you guys get more familiar with them. Yeah. Alright, so this one, we've got 2x plus 14 over x squared plus 2x minus 3.
Awesome.
Alright, so we know what the left curve looks like. We know what the middle curve looks like. We got a point for that one. Now we need to know this curve on the right. So I'm going to plug in 2, because it's a little bit to the right of the asymptote. 18/5, what is that decimal?
3.185.
18/5.
Fifth, sorry. You can do this in my head.
3.
That's
3.2. Yeah.
3 something.
So that's up 3 or down?
To the right 2, because I plugged in 2. So to the right 2, up 3 point something. 18/5 is 3.6. So to the right 2, up 3.6. All right. So here's what your graph looks like.
my thing went.
No.
All right. Range. All right, we got to go from down to up. So negative infinity to, and it looks like -3, but do we know that for sure?
No.
No, we got to figure out where that maximum is, don't we?
Yep.
Because we got to know, because we know it stops, and then there's a gap, and there's no y values in that gap. We got to have accurate numbers. So on your graph, what should we do?
Go down.
Second choice.
Second trace.
0. 5.
Maximum, number 4. We want to know what the
Watch out.
maximum is. And I'm looking. Here we go in here. So I want to be on the left side of it.
And
And then I want to get over to the right side of it. All right. So it's almost at -3, but it's not quite. It's a little bit off. So for max, I'm going to go ahead and write, let's do 3 decimals. So I'm going to say -1.343, comma, -2.914. Okay, so there's the point. So for our range, we go from negative infinity up to the maximum. And what's the y value right there? -2.914. Does this get a parenthesis or a bracket? It gets a bracket because if you ask me where it is, I can say right there and put my finger on it.
So bracket means exact.
Bracket means it actually is included. All right, and then we skip these y values right here. We don't have them. So what's the next y value you can see as you go from down to up?
0.
The next y value I can see is 0. Does 0 get a bracket or a parenthesis? A parenthesis because it's an asymptote. It's a number you're not going to touch.
Is that negative infinity?
And then it goes up forever. So positive infinity. All right, are we ready for increasing, decreasing?
Yeah.
So we draw our stick figure on the left side.
He's increasing.
Yep, and what's the x value right here?
0.
The x value?
Oh, 7. -7.
The x value at the arrow.
Negative infinity.
Negative infinity, perfect. That's my bad. I did that last time too. And then so he is increasing. He's walking up. And what happens when he gets to the dotted line? A UFO takes him. He dies. What is the x value at the dotted line?
-3.
-3. Okay, so there's one answer. That stick figure is gone, so on the left of the next curve we start with a new stick figure. And what is the x value at this dotted line?
Negative 1 point. Oh no, that's a
-3.
Negative 3, that's the x value there.
What am I saying?
2.
And then, but we want the x value, right?
Oh, 1.3. Negative 1.3.
So this stick figure guy is increasing up until he gets to the top at negative 1.343.
Then he decreases.
And then he decreases. And what happens when he gets to this dotted line?
He goes from.
He dies. He falls and dies.
Similarity.
What's the x value here?
1.
1. The x
So is
value
that
is 1.
infinity or negative infinity?
Right here, it's not an infinity or a negative infinity because you're thinking that it's going down. We care about the left and right. We want the x value, and the x value is a 1.
Oh.
All right. So we got to start with a new stick figure. He starts up here on the left of that curve. What is the x value up here? 1. And what is this guy doing?
Flying.
Going down.
Decreasing. It's like he's going down a slide. And decrease, decrease, decrease. And what's the x value of this arrow? Infinity. Okay. So let's go ahead and write these down. The first one is increasing. So we increase from...
Negative infinity to negative 3.
Okay.
And then the other increasing is negative 3 to negative 1.343.
Okay.
Then there's decreasing is negative 1.343 to 1. And then 1 to infinity. So I just
Okay.
put 1.
So when we do these for increasing and decreasing, it is very important you label your picture. Because these get real crazy real fast. Again, we are running into some problems that are a little bit more pre-calculus level difficulty. If I give you a question like this and it is not extra credit, I'm going to give you more simple ones. If it's this level of difficulty, you're definitely getting extra credit for it. What should we say for minimum? None. There's never a point where it goes down and then comes back up.